Welcome everybody to this pop-up session of my live weather and climate office hours. Again, I sometimes hold these pop-up sessions during periods of exceptional or at least interesting weather. This probably falls somewhere between exceptional and interesting, but definitely a very active day. And there is some exceptional record-breaking rain to talk about over the past couple of days. This might be a surprise if you're in Southern California or even if you're south in the Golden Gate Bridge. But parts of the San Francisco North Bay actually saw their wettest day and wettest two-day period on record with this storm that is now continuing with heavy rain in exactly the same places as we speak. And there's actually a very active radar picture to look at today as a band of heavy to locally torrential downpours is now moving and strengthening as it moves across the North Bay. And this is finally the part of the system that will bring heavier rain and stronger wind to the rest of the Bay Area and points east, including Sacramento, and points eastward as the day goes on today. So this storm is not over yet. In fact, it is yet to peak in some places, although it has already peaked in others, and I'll get into that in just a moment. And I also wanted to reflect on some other related pieces of science and statistics that have been talked about recently in the context of some recent papers that have been published on the scientific side and some news articles that have covered that content in the setting of extreme precipitation and precipitation trends in California. So I'll talk about that a little bit today too, since I think we'll have some time for it. As always, this channel is sponsored by Reask, a company that's rethinking extreme weather risk in a warming climate. And as always, it's helpful if you share these videos and the channel, including while it's live. I think that actually is one of the things that the YouTube algorithm likes. So the more you can engage with these videos while you see me live on screen, the better it is for growing the channel. So thanks for doing that. One thing I might do, I actually might start out right now by showing some graphics on screen, and then I'll return to the talking head version a little bit later and answer questions at that point. So you'll see a brief transition with the infinite mirror, and then the first thing I actually want to show is not a map. Well, I guess this is a map first. And let me just make sure that you're seeing what I'm seeing here. It's always just to double check that everything is showing up. Yep, okay. So this is the NOAA Precipitation Atlas, and it's actually something that I've been quite critical of in the context of the fact that I think we systematically misestimate the likelihood of extreme precipitation events using extreme value statistics to extrapolate well outside of the observed distributions of precipitation events. So for example, this precipitation atlas, this is for a point right near downtown Santa Rosa, so where the red cross is on your screen. And the reason I mention this is because this is a part of the state that has seen record-breaking rainfall now with this system. So central Sonoma County, including the most populated parts of Sonoma County, there has been widespread and locally significant flooding, despite the fact that there was almost no rain before this event. This is essentially the first major event of the year, and it has already become the wettest rain event on a 1 to 2 day period on record in this part of the state. Widespread flooding, fortunately not extremely serious flooding, but that's mainly just because it had been so dry leading up to this. It would have been a different story if this were in the middle of a winter storm sequence. But I wanted to show something I don't usually show on screen. This is just a table of values. I'm going to bring up my drawing tool since I know it's a lot of data to show all at once, but this is really what I want to illustrate. So yesterday, or 2 days ago actually, Santa Rosa saw almost 8 inches of rain, I believe it was somewhere around 7.93, 6.93, so about 7 inches of rain. According to the NOAA Precipitation Atlas for this region, that puts us squarely in this territory of about a 100-year recurrence interval for a 24-hour period. Records here go back about 100 years, so it makes sense that depending on the specific recording site that we were seeing, that 6.93 inches is at the upper end of the estimate of what a 100-year event would be in this part of the world. So really, maybe it was between a 1 and 200 year event, because the average 200 year event is only 6.26 inches, but look at the range from about 5 to 8 inches, the statistical uncertainty there. So this, the 24-hour rainfall, the NOAA Precipitation Atlas, I guess, does a reasonable job of estimating where that would fall. What we saw is within the uncertainty bounds of a 1 to 200 year event, and therefore, with a 100-year record, not surprising that it was record-breaking. But now we have a 2-day total that's getting close to 12 inches. And here's the challenge with that. The average estimate in this region for 12 inches in a 2-day, 24-hour period is only about 10 inches. And this is ostensibly the 1,000-year event on average. This is where the problem is, I think, with these precipitation atlas events, is they tend to underestimate the magnitude of rare events. Was the 2-day precipitation in Santa Rosa that we've seen exceptional? Definitely. Do I think it was truly a 1 in 1,000 year 2-day rain event in this part of the world? Probably not, right? And technically, that's within the uncertainty bounds of nearly a 500-year event, but that still would be considered an exceptional rain event in this world. So I don't want people to focus too much on the numbers, but to point out that the 24-hour rainfall that Santa Rosa, Sonoma County has experienced during this event is exceptional and record-breaking, but the 2-day rainfall being around a foot, and again, this is not, in the Venado or the coastal hills where we get these double-digit totals every winter. This is in the flatlands of the valley. In Santa Rosa proper, having about 12 inches of rain in a 48-hour period, where it's still pouring at the moment, by the way, that's a really rare event. Do I really think it's a 1,000-year event? No. Do I think it, even if it was once a 200-year event, do I think it still is today in a warmed climate? No, but there are some caveats with that statement that I want to talk about later in terms of the recent publications. But this has been a really amazing, exceptional rain event for places like Sonoma County and some adjacent places where this is literally the heaviest rain event on a 1 to 2 day period that we've observed, period, in this part of the state. So that is quite notable. There is widespread flooding ongoing, but it is not necessarily severe flooding at this point because we had dry conditions going into this event, just illustrating how important that can be. Okay, the next thing I want to show is the satellite imagery. This is probably more interesting to folks. Just double checking that I'm seeing what I'm supposed to be seeing, or that everyone is seeing what they're supposed to be seeing on the screen here. Yeah, so I'll bring back the drawing tool because there's some quite interesting features. Just double checking that the stream looks good. Yep, looking good. Okay, so where do we go here? Yep. If I were an on-air meteorologist, I'd have some more better tools at my disposal. But in any case, the interesting features here. So over here, we have essentially these popcorn convection clouds. So over in this region, these are showers and isolated thunderstorms out of the open water, indicating cold, unstable air. You can kind of see that these are moving generally toward the coast, but they're still pretty far offshore. But it's just an indication that there's slightly more unstable, colder air behind the cold front. The cold front is somewhere in here right now. I don't know exactly where it is, but it's something like this. The air in front of it is very warm because this is still the atmospheric river ahead of the cold front. So this is the AR. And we still see all of this deep subtropical moisture flexing northward ahead of it. And now it's interacting along this cold frontal boundary to produce some quite heavy precipitation that's moving right now right about through here. So this is the axis right now of very heavy precipitation that's going to move slowly eastward through the day and potentially intensify a bit. The other feature I wanted to illustrate is down here, sort of this horizontal feature, and this is a jet streak. So this is an enhancement of the jet stream locally, where it is locally stronger than the rest of the jet stream. I think what it's doing in this case is it's enhancing this at the base of the trough. So right now the broader trough is kind of like this, but this jet streak right around here, and you can see this if I am a little bit more careful with my drawing, you can see this enhancement of this high-level cirrus clouds. This jet streak right here is what's enhancing the precipitation upstream right now in this region. So this is why today this is going to be sort of the axis of heavy precipitation. The north coast, I think, is largely done. They'll get some showers, isolated thunderstorms later, so there could be heavy downpours. But for the most part, we're talking about heavy rain potential continuing south of this line today. So if you're north of the line, the worst of the flooding has probably already occurred. But in this vicinity, there could actually be re-intensification of flooding from the rain bands I showed you, or I will show you in a moment on radar. And so I want to zoom out and just show, that's the wrong zoom level. Here's the Fujiwara effect that I mentioned yesterday, multiple low pressure systems spinning around a common center. Here's one low, here's, well, let me let these stick. Here's one low, this is the original bomb cyclone. Here's the second low, this was the new bomb cyclone that formed yesterday. And now you can kind of see there's a weak spin of low pressure off the coast here. So what we have is essentially we have three different things spinning like this. All cyclones, of course. The strongest one is the one I'm drawing right now off the coast of Washington. But this is the general orientation of things. They're orbiting around a common center, which is roughly this. So if you notice, the whole thing is kind of spinning like this, and this is that broader trough that I mentioned, and this is the general direction of orientation. So what we have are these different features pinwheeling around a common center, which is approximately here, just based on eyeballing it. What we have is this the primary low is generating this front like this that's moving, the cold front is moving like that, and then there's some warm front over here that's moving in that direction. But overall, this is a pretty interesting and complex picture. It's unusual to see such a classic Fujiwara effect with these multiple well-defined low-pressure systems spinning around a common center, two of which were, again, cyclones that underwent bombogenesis. So this one and this one. This is the original quote-unquote triple bomb, in the sense that it deepened at a rate almost three times that required for the minimum threshold for bombogenesis. This one did not do nearly as much, but it still met the benchmark, so just a regular old bomb. This one has no real superlatives attached to it, except that it is the third center of circulation within this broader gyre. So a lot of interesting things going on satellite. The other interesting thing that's worth noting, this showed up in the WeatherWest comment section earlier this morning. Look at this little feature down here. Essentially a 1,000-mile long roll cloud. This is just a feature that we see occasionally. This is a particularly elongated one, but this is at the forward flank of the AR. So the broader AR is kind of in this vicinity, but at the leading edge of it is this really long roll cloud, probably not producing anything too dramatic, but just an indication of some convergence in the atmosphere along the leading edge of that atmospheric river. So a bit of a curiosity there. But all in all, this is quite an impressive satellite picture across the west. All right, so the next thing I want to bring up is actually this is a NOAA product from the sub-branch of NOAA that does extreme precipitation prediction regionally. I just want to zoom in on this. This was just issued at 11:44 a.m. so Eastern time. So this is less than 2 hours ago, so this is valid for much of the rest of today. This is still relevant. Essentially highlighting more or less the same region that I did. They have a slightly broader purple zone here. I think we can kind of narrow it a little bit to anyone who's ahead of the cold front. So sort of really where this orange highlight is. This is sort of the region. This includes Sacramento, San Francisco, and much of the North Bay, really from Santa Rosa southeastward, in the greatest risk of heavy rain with flooding today, with, again, noting localized significant impacts possible, so more than just nuisance flooding in some places. Again, this is unlikely to be in the form of like major river flooding, so the Sacramento River is not going to flood. There will be minor to moderate flooding on the Russian River, maybe even the Napa River, certainly the Eel River, but perhaps not major flooding. But the bigger concern are the smaller watersheds, so the creeks and streams and the urban areas, which in many ways are the things that people interact with more in more places, their day-to-day lives. And again, this outlines where the atmospheric river is interacting with that jet streak, consistent with what I just mentioned. And this discussion is interesting. Flash flooding is possible today, and there could be some training. What does training means? Well, it means that you may see, if I bring the drawing tool back, it means that you may see bands of precipitation that have roughly this orientation, like this, and instead of moving like this, they don't do that, but they actually move parallel to their own axis, so in this direction. So you can see it's sort of like a train along the tracks. It just keeps moving in the same direction over the same places. You can see why that would cause some concerns, given how saturated the ground already is up there. Okay, so that's not what I wanted. Okay, there we go. Yeah, next thing, actually, I'll bring up the radar because it's quite interesting. All right, so there's a lot going on here. I'm going to bring up my radar drawing tool, which is different. So this is the axis of heavy precipitation as it is now. It's essentially, this is where the atmospheric river is. The cold front is sort of aligned right here, so it's sort of like that's the leading edge of the cold front. It's somewhere near, or maybe it's somewhere actually not far from Santa Rosa right now. So this is a broad axis of heavy rain now over Marin County, eastern Sonoma County, all of Napa County, and now spreading into Yolo County, Sacramento County, the Delta. This wall of rain is what will bring stormier weather to the San Francisco Bay Area later today. So down on the peninsula, it's just light rain right now, if anything, but this is going to pick up later. Not as much rain has fallen there previously, so the flood concerns are lower, but there still could be some urban flooding because these rain rates in this band are locally pretty intense. And especially, I'm going to pause this in the earlier frames. Well, maybe I won't. It doesn't want me to let me do that. What you can see is in this narrower region over Marin, Sonoma, and Napa County, there's this feature called a narrow cold frontal rain band, indicated by that brief burst of oranges and reds. That's locally torrential downpours, and that's going to pose some problems given that there is already widespread flooding in this region right now. So the good news is the far northwestern corner that's gotten some of the heaviest rain is finally behind the main band at this point. But really, from Santa Rosa southeastward, there is this region that's got overlap between places that have seen some really heavy precipitation in recent days and which is currently seeing a renewed pickup. If I zoom in towards Santa Rosa, you can kind of see that the heaviest rain right now is now just southeast of town, but it's kind of been back building, and we now have this area sort of about to move into Santa Rosa that looks like it's intensifying. So the flooding in Santa Rosa area is likely to get worse from where it currently is over the next hour or so at least. And it could be, and there could be significant new flooding developing in southeastern Sonoma, parts of Marin County into Napa County, and even western Yolo County from this band, because this looks like it's going to stick around for at least a few more hours before really moving through. In fact, there will likely be some additional heavy precipitation that develops back here and continues to move inland like this. So it looks like the back edge right now is here, and that's currently true. But given that jet streak I mentioned, it's quite possible that additional heavy rain will fill in back here and continue to train in this direction, as was indicated in that NOAA advisory for today. If I shift over to the Sacramento radar, you get a better view of what's going on in this part of the state. Again, this radar underestimates rain in this region, so you can kind of discount it. But you can see that the rain right now is lighter, but picking up across the southern Sacramento Valley. But where it is now really heavy again is up in Butte County, where from the eastern foothills near Chico down toward Grass Valley. This corridor today could see potentially 6 or 7 inches of additional rain today in this region. So there is significant concern for flooding here. Again, a lot of this is the area that burned not so much this summer, but actually in a few years ago in the Dixie fire. So although that burn area is now a few years old, it's massive, and we've seen previous instances of flash flooding and debris flows within it during heavy rain events. That is a concern today because this rain is actually going to intensify further and persist for most of the day. So there could be some issues in and downstream of the old Dixie fire footprint, which is huge in this region. And then also, it's a little less clear if we're going to see much additional heavy rain sort of in this area, which is generally speaking where the Park fire burned earlier this year. So the far southeastern part of the footprint near Chico would be probably the greatest risk. There is flooding on Highway 99 and in the city of Chico right now. It's not severe, but there is some potential for the back end of this rain to sort of start training over this region and to intensify. So this could pick up, but it's not quite clear. It's possible that Chico is actually pretty close to the dividing line where the bigger flood risk will be south and east in the foothills, and then again to the southwest, closer to the coast ranges in Sonoma, Napa, and Marin counties. These are the areas I would highlight as having greater flood potential today. But as you can kind of see, though, the radar in the first couple frames doesn't look too impressive, but it really has intensified a lot, even as I've been speaking in this region. So this is a significant concern for later today. And if I go over to Eureka, you can see that there's not nearly so much to talk about. There's scattered showers, maybe some isolated thunderstorms, but really northwest of about this line, this region, the event is largely done. But southeast of this line, there's potentially quite a bit more to go today. All right, and then looking then at a few of the creek levels, this is by the way, this webpage is much better than the one that the Weather Service had even last year. So water.noaa.gov, you can get real-time information on stream gauges much better. I'll look at some in Marin County right now. This is Fairfax Creek. You can see that it's still well below flood stage, but it's starting to spike with the ongoing downpour right now. Looking at some of these other ones, they're sort of just starting to respond again. We go up toward Dorvado. We again see that weak response, I think, and a stronger response on some of these streams that are not tidally influenced. Just trying to see some of the ones in the foothills here. Some of these, over the course of this event, have already gotten up to moderate flood stage earlier. This was a lot of the flooding we saw earlier. This is Colgan Creek near Sebastopol, which was actually up moderate, getting close to major flooding earlier. And then places that are still seeing moderate flooding now, Green Valley Creek, Mark West Creek, which actually has yet to peak and may end up peaking at major flood stage later today. That may depend a bit on how intense the rain is to come. But other creeks in Santa Rosa seeing huge spikes but not necessarily reaching flood stage. Again, it's the smaller, faster responding systems that are generally having the largest responses given the earliness of the season and how dry things were. Russian River currently actually at flood stage, minor flood stage. Could get close to moderate, but probably won't see a major flood there. Another creek at flood stage here, the Russian River at Guerneville, also anticipated to reach minor to maybe getting close to moderate flood stage. That's not that dramatic in this part of the world. People are used to it, but it is remarkable. Look how much this came up, though. The river was essentially had almost no water in it. Really, essentially just minimal dry season base flow, and then immediately rising all the way to minor, getting close to moderate flood stage from one rain event, one record-breaking rain event. That is notable. Napa River, again, nothing concerning. It's going to get up close to action stage, but that's not really going to pose any issues. It's just a nice flushing of the system. If we zoom out, look at some other creeks. Navarro River, again, looks like a bit close to moderate flooding. Russian River near Hopland getting up just to minor flood stage about now. The Eel River was previously expected to get up to major flooding. The peak now lower. In fact, we're getting close to it now probably. Moderate flooding, so again, still impressive given that the flow was at zero essentially just a couple days ago. We're now up at moderate flooding, but less significant flooding up here, mainly because the atmospheric river stalled farther south. So Santa Rosa, Sonoma got even more rain than expected. It was somewhat at the expense of further north, which posing some more problems for places near Santa Rosa, but fewer problems further north. If we look up some of the creeks up near Redding, sort of at minor flood stage here. Sacramento River, technically reaching minor flood stage, but again, that's well within the flood control system there, so that's not actually causing any problems. Those are just high flows. Some of the concerns surrounding some places in the creeks up here, looks like these creeks are probably far enough north to avoid any significant flood concerns right now. A little more rise on some of the creeks as we get farther south and east, given the incoming rain. But again, it helps that it's been dry leading into this, so we're not expecting big time flooding. I still think the biggest issues are likely to be in the North Bay. We've already been seeing some places are already experiencing flooding. Again, Mark West Creek notably potentially reaching major flood stage right later today with some ongoing heavy rain. Now, just reminding folks what that looks like right now when I bring back the relevant radar. These are places that are currently getting moderate to sustained heavy rain once again. Seeing again, although Santa Rosa is a little bit on the northwestern side of the heaviest axis right now, we are seeing some of that water, some of that rain fill back in right now. So there is light to moderate rain redeveloping, could become heavy at times within Santa Rosa. So that's the concern there. And again, that heavy rain really building into Yolo County now, finally starting to move into Berkeley, San Francisco Peninsula. All right, so I'm going to take a break for a moment, take a look at some comments. That's the wrong screen. I need to I'll bring my face back for this. Take some comments, and then there is one other conversation about the broader context, including the climate change context of all of this. I'll talk about that in a minute. All right, sip of water here. Let's see what comments we've got. Zepp mentions nearly 10 inches of rain up my way in 24 hours. That is a very impressive 24-hour total. I can't recall exactly where Zepp is. I know he's way north, far northern California, I believe. I don't remember the exact location, but not surprising. It's been a very wet region during this event, as have many areas. Let's see what else we've got here. There's a comment from Agamemnon that we're now fully primed here in Sonoma County. What does the next month look like from a flooding perspective? I do think there's going to be a good chance to dry out. So I'm not super concerned after this event. The conditions were relatively dry to begin with, so despite record-breaking rainfall in Sonoma with this event, there's no immediate indication of follow-on storms that would be concerning, even though there might be more rain next week. Probably at this point not concerning rain. Thomas mentions that near Petaluma right now in Sonoma County it's been kind of nuts, and right now just based on looking at it, looks like it's about to get yet another round of renewed heavy rain in the next 30 minutes there. Comment from Marilyn that right now in Richmond there's very heavy rain, so clearly this has finally started to move in. Pleasant rain in Sacramento. I think that's a nice way to describe how it's been so far. It will pick up, but Daniel mentions that it's intense in Chico right now, so this would be from that radar signature that I was showing earlier. It does look like it's picking up, just as the rain in the North Bay is actively intensifying as we stay on this live stream as well. The question, is training the same as squall lines? No, not necessarily. Squall lines actually, they can exhibit training behavior, but they can also actually, squall lines sometimes move through very quickly in non-training fashion, so they can have almost any trajectory, whereas training bands of rain or thunderstorms just move repeatedly over the same places. So there can be overlap. Squall lines can train, but not all squall lines do so by definition. Pouring in Durham. So again, the rain is continuing. Mark mentions that at the home station, 14.42 inches for the event. So this is essentially a less than 3-day event, technically, in terms of most of where that rain fell. Only an inch so far today, so of course the intensity is lower. Depending on which side of Santa Rosa you're on, you might get another big burst soon, or you might be mostly done. All right, let's see. Yeah, this is going to result in a nice green up of the grasses. This is going to be for most parts of the state, this will be the increment of rain needed to get the green up underway. Dale mentions, seems like snow levels in this area are a little lower than expected or trending lower. Well, they're definitely going to be lower later today. And honestly, a lot of the Sierra Nevada just has stayed completely dry or mostly dry during the warm phase of the storm, so they may end up getting a higher ratio of snow. Not a particularly cold storm, but the snow levels will drop behind the front today, so there will be some nice accumulating snow, just not a tremendous amount of it. Steady rain in San Francisco now, coming down. Eastern Napa County, Joyce mentions 7.17 and now currently pouring. So these are the areas that today could experience some rather significant flood risk on the creeks and streams in urban areas, because that's a lot of water already, and there is still inches to come in some cases today. How much rain has fallen up north? So I mentioned previously that there was the potential for anywhere from 10 to 20 plus inches in some parts of Mendocino and Sonoma counties, and that has already been realized. There are many observing sites in the double digits, and there are now several observing sites that are now already above 20 inches for this 3 to 4 day event. So pretty much those initial predictions were rather good from the models. The exact positioning of the atmospheric river stall is almost impossible to completely get right in advance, so I know lots of folks are complaining. I never quite understand that, but it is just an illustration of the fact that California is a big state, and we don't have the scientific ability to pinpoint precision days in advance, assess exactly where very subtle, small-scale features of a very complex pattern. I mean, think about the complexity of the motion on that satellite imagery that I showed at the beginning. In terms of just how complex that motion is. There's two previously rapidly or explosively intensifying bomb cyclones with one less rapidly intensifying cyclone spinning in a circle around a common center, kind of like planets orbiting or various celestial bodies exhibiting complex orbital patterns. But it's actually more complex than the astrophysics version of it, because the analogy would be as if the planets rapidly changed in size, and so their gravitational forces were changing rapidly from day to day and even hour by hour. So that's a degree of complexity that you don't have to deal with orbital dynamics that come into play when you're talking about the fundamental first principles physics approach to understanding the complex interactions when you bring in the thermodynamics of the system, in addition to the sort of the the fundamental physical dynamics. So point being, this was a pretty good forecast from several days out. The forecast was that where the AR stalls, you'll see 10 to 20 plus inches of rain with potentially record-breaking rainfall. That is exactly what happened. It happened within the uncertainty range of where we thought this could occur, a little bit on the southern end of it. So originally it looked like it would be more of a far NorCal focus. It ended up being slightly less far NorCal, still north of San Francisco almost exclusively. So really not that far off, but not quite as far north, a little bit farther south than expected, and that's why Sonoma County and Napa County, southern Mendocino, and parts of Lake County have been hit so hard in particular, and continue to be inundated for the most part right now. So there are places that have seen over 20 inches of rain confirmed, and storm totals, peak storm totals for this event will probably end up being around 25 inches in the very wettest places, but arguably more impressive are the lowland places like Santa Rosa that will end up in the 10 to 15 inch range. That is a lot of water for the lowlands of Sonoma County. And the next question is, how hard is it to forecast a stall? I think I just covered that. Very hard, but the models have done a pretty good job, but they almost never get it exactly right, even a day in advance, and so you just kind of have to wait and see, and now we're seeing, essentially, is my answer to that one. Just under 9 inches, Warren mentions in San Anselmo. Looks like you're going to add at least a couple more inches to that, to the 3-day storm total, so a decent chance that San Anselmo ends up with a double-digit storm total from this event, given that the heaviest rain of the event is now occurring as we speak and will continue for at least a couple more hours, so could get a couple of inches in several hours, and that's going to result in some flooding. So that is right in line with expectations there. Amy mentions a heavy, steady rain in Grass Valley. Not a lot of wind, but there was previously some wind that knocked down some trees. So yeah, not a huge wind event in most of Northern California, but the first of the season does tend to bring down preferentially more trees because if they've been weakened over the summer, or if they still have leaves. In this case, I guess it's a pine tree, so the deciduous leaf issue is not there. But some trees still have their leaves, and so that gives them a larger surface area. It's easier to bring them down with wind gusts. All right, so given that gets us through most of the on-topic questions today, again, I'm never able to answer every question in every session because there are specific topical foci during each event. What I'd like to do then is bring back briefly the radar. So I'm going to share my screen. Once again, you'll see the infinite mirror briefly. Now you'll see the radar. And I'll talk about this, and then I want to talk a little bit more about the long-term climate context for about 10 minutes or so. So once again, we see this, as I mentioned, in Santa Rosa, as I was talking about earlier in the conversation, the heavy rain has rebuilt over the area. So even though it looked like the line was mostly east of Santa Rosa, it's now filled back in, and it might continue to do so for the next hour or so. So moderate to heavy rain redeveloping in the Santa Rosa area. That's going to really push some of these creeks out of their banks. Again, Mark West Creek potentially reaching major flood stage in a few hours, so that's going to cause some problems along with other places. I would expect to see rapid rises on creeks in Marin County now over the next couple of hours. I'll take a look at that in a moment, and probably also in Napa, maybe parts of Yolo County as well, as all of this fills in. Folks were reporting heavy rain beginning in Richmond. That makes sense. Berkeley probably just starting to. San Francisco, the whole peninsula now getting in on the party, so to speak. Not too surprising. And again, this rain is intensifying. So rather than weakening as it moves on shore, notice how the rain band is becoming thicker and more intense as it moves inland. So it's actually, it's probably going to be more impressive than it looks given that jet streak I mentioned. Remember that jet streak I mentioned off here? That's sort of energizing the storm, pushing it, sort of expanding it at the base in this region. That's what we're seeing right now as all of this fills in. Even in the East Bay, starting to see some rain pop up out of the ether, so to speak. Sacramento radar also filling in quite a bit And you can see now that the heavy rain is now moving into the valley. Quite heavy rain up to the north. Folks were saying that there was a downpour in Chico. You can kind of see how that was earlier. It looks like it's drying out again. But to the east, in the foothills above Chico, especially southeast of Chico, again, this is the area where the other area where there could be some significant flooding concerns later today, because this is going to continue for some hours. See this area of rain back building? This is going to fill in and intensify and move back in. So you're not done yet with the rain in Chico or in the foothills above Oroville. So maybe a slightly less concern up in this region with the park fire footprint, although there could be an isolated thunderstorm downpour, and if that sets up over the burn area later today, that could produce flash flooding and debris flows there. Bigger concern though, actually further south, just a bit further south, with the older burn areas like the Dixie Fire footprint, as I mentioned earlier. And then some urban, I mean, it's going to be a messy drive on I-80 for the rest of today. Some urban flooding possible down in Sacramento, even though there hasn't been nearly as much rain there as in other places. You can just sort of see this filling in. If I sort of take the long view, just if you squint a little bit, see how this is filling in and intensifying over time all in this axis? This is where the cold front is converging with the atmospheric river. All right, and there's something else that I wanted to show. Actually, let me just take a look at the creeks really quick. I'll refresh this while I'm on, just since some of these are probably starting to respond reasonably quickly to the ongoing downpour. I'm just looking to see if we're getting that kind of response that I'd expect. That's looking Marin down at Fairfax Creek. Yeah, so we're starting to see that. It's nothing concerning at this point, but it is starting to spike up a little more again. Corte Madera Creek starting to as well. Nothing too dramatic, so I won't belabor the point there. But I wanted to bring up the broader context right now of extreme precipitation. This is a paper from my colleagues at UCLA that's been getting some attention in the news recently about the lack of a detectable intensification of cool season precipitation. Cool season, of course, being sort of the winter plus some adjacent months that are winter-like, so like November through March primarily, in most of the western United States, including California. And I think this is a nicely done paper. I think it's got a lot of pretty thorough statistical analyses and dealt with some really challenging issues regarding the fact that, as I mentioned last time, the precipitation data sets we have available at our disposal are just not very good in a lot of ways, particularly when it comes to extreme events. There's a lot of missing data. There are actually fewer weather stations today measuring measuring precipitation reliably than there were several decades ago. So it gets difficult. But the real conclusion here is that we don't yet have a clear signal for increasingly extreme precipitation in most of the western U.S., at least through 2023 as measured using this type of rain gauge data. There's a lot of caveats in there, but there's a couple of interesting things that I just wanted to highlight here. One, and I'm scrolling down so I can show a couple of images here, and I'm going to bring my drawing tool back so I can sort of focus attention on this plot just in the upper right here. But this is essentially the trend in the wettest calendar day per year from 1950 through 2023. And really the point here is that it's kind of a mixed bag depending on where you are, and in general there aren't very strong trends in either direction in this data set that's clearly detectable when you look all the way back to 1950. So depending on where you are, there's some places where it's actually decreased a little bit, although usually not statistically significantly, or where it's increased a little bit, also not all that statistically significant. But if you look at California in particular, there's not a really clear brown or blue trend, but in particular, there's not a clear wetting. Now, I often say that climate change is increasing the likelihood and the intensity of extreme precipitation events. This does not change my assessment there, but it does, I think, add an interesting dimension to thinking about what we mean when we say that and how much we can infer from observations, historical observations. So I want to bring up one more chart here from this paper. Well, actually, maybe I'll bring two more. Or several more. Yeah, we got the time, why not? So one interesting thing here, and this is another finding, is that the water vapor flux on the wettest days of the year, and this is from the same paper, my colleagues find a significant decrease almost everywhere on this map. Oh, I'm sorry, that's not what this is showing. Excuse me, this is just the background correlation. The trend over time, though, is in some regions significantly decreasing. Well, this is probably not the best map to show this. Let me actually bring up the next one here. So here's what I wanted to, here's a better illustration of this. So this is the long-term trends and over a 73-year period since about 1950 of several different quantities on a map. Maybe this is more interesting to look at. So this delta QV, this is the vertical integral of water vapor flux. So essentially how much water vapor is in the air multiplied by how fast the air is moving over the whole vertical column. Now, if you squint on this map, it's generally positive values in this whole domain. So you see a lot of blues. That means that the water vapor flux, anywhere where there's blue, has increased over this period, which again is almost everywhere on the map. But there's a couple of small patches where it hasn't, and generally over the western US there's not a huge trend. But if you look at the total amount of water vapor in the air, the whole column, it's blue almost everywhere, and it's more blue in some regions than others, and these horizontal lines like this is significant stippling. Let's ignore that for now. So there's stronger increases in total atmospheric water vapor north and east of California, but there's also some increases out over the Pacific Ocean. The thing that's increased pretty unambiguously is temperature, just about everywhere. So surface temperatures, of course, have warmed essentially in every location on the map. But what the combination of the relative lack of increase in the total column water, at least relative to other places, plus a decrease in relative humidity across the interior west is interesting. And so what we see here is there's increasing water vapor flux in a lot of the regions upstream of California where our winter storms come from that bring us atmospheric rivers and heavy downpours in winter. But locally across the west, especially the interior west, we've actually seen a decrease in absolute humidity over the period at the surface, even though overall the amount of water vapor has increased in the atmosphere. So the surface is doing something different than the total column. That's interesting. And the net result is that what we essentially see in the long run is what we showed in this plot, where we don't have a really clear trend in extreme precipitation events yet across the west, at least when it comes to the single wettest day of the year. But here's my perspective on this, and this is yet another figure from the paper. Here is what climate models say should have happened during this period for essentially 95th percentile precipitation, so fairly wet days. It pretty much shows that almost everywhere it should have increased at least a little bit, including a good chunk of California. It's not a huge increase, but it's a 10-15% increase, especially in Northern California, which is nothing to sneeze at if it had occurred. But we haven't seen that, right? That's what the observed trends tell us, at least to the extent that we believe the surface precipitation gridded data sets. And there are problems with these data sets, and I'm not sure that we fully can trust them. But that's maybe a story for another day. But I think the most interesting piece of this is these short segments of dark colored curves. These are the observed trends, so and different regions. So the purple is the Pacific Northwest, orange is California. You can see the other regions as labeled. But these are the trends that we've actually observed, the solid curves that are colored. And the trends that the model had predicted on average are the dark black curves over time. So you can see that, for example, in the era before 1950, when there wasn't a whole lot of global warming, either in the real world or in the models, the likelihood or the long-term average of the individual extremely wet days didn't change very much. There's a little bit of an increase, but it's pretty weak up as we get through mid-century, and actually remains weak right up until around the year 2000. So I'm going to get rid of these circles here. But notice what the black lines start doing in climate models right around this point in time. So this is in the climate model world, right where the black lines start to deviate from the long-term average in a more notable way. Now, my colleagues, one of whom is an eminent statistician at UCLA, they have a very formal way of defining the time of emergence, which is essentially defined by this part here. So essentially all of the orange dots are the time in history, at least in simulated model world history, where the signal for extremely wet days in a warming climate emerges, the median being the dark black dot in different places for different regions. And I'm going to get rid of my drawing because I'm making it a little bit messy. The point is, and each dot represents a different iteration of this of a climate model, so different ensemble members. So, for example, in the Pacific Northwest, there's one climate model that says the time of emergence was actually before the year 2000, so this is now 30 years in the past. But there's also a member of a model that says it takes until about 2080 to see a statistically robust emergence. So there's actually quite a huge range, but the average is closer to black, so in the Pacific Northwest saying 2050, but there's quite a few model members saying in the Pacific Northwest this emerges, well, this is right about now, this is about 2025. And you can see how this is different for different regions. But notice how California's time of emergence is shifted late in this in the models. Now there's at least one model that says again that we've already passed the time of emergence in that model, and there are several other models that say it's imminent. But here's my point about this. The trend that we've observed in California, which is in this case, this ends, the moving average ends around essentially the 2010s mega drought, the peak of the record-breaking drought severity in California. So this is heavily biased by that really strong drought that we saw, and there's no doubt that it occurred. It did occur, and at the end of this particular observed time series, it looks like extreme precipitation events have decreased. But I'm not really sure this tells the whole story. I don't think this is necessarily wrong, but what we're seeing is not what climate models suggested should be occurring, and there are interesting reasons why that might be the case. One could just be random bad luck. Are we just seeing this unlikely iteration of natural internal climate variability that's brought us this period of elevated drought in this window? There's a pretty strong argument for that to just be the product of random chance, because the last couple of years already, now you can't really extrapolate individual years, this is a 21-year moving average, but we'd be well above the trend line for the individual years, the past several years. So that's not yet reflected in the observations. But here's the problem. When you use a 21-year running mean, you're always looking backwards in time, 21 years. So you don't have 21 years of our present climate. Just to remind folks, as we are about to enter 2025, we are approximately here. And if you look at where that line intersects the climate model black line here, even in California, that signal is starting to be elevated. And I hesitate to use the word emerge because we know that formally, statistically, it doesn't emerge till later. But this is where there's an interesting philosophical difference, I think. If you needed to prove with robust statistical analysis that the signal for increased extreme precipitation events in California was likely to occur in climate models, you would need to do something like this. But the reason why it's so late is that the background variability is so high. So we talk about signal to noise ratios in science a lot. The signal being the thing we're trying to discern, and the noise being random or pseudo-random variations that make it difficult to tell when that signal has occurred. Has the process of interest occurred or not, given that there are lots of natural random variations that can occur and give us a noisy signal? The reason why California's formal time of emergence is so late in climate models is because the background variability is very high. We have an intrinsically high level of swings between drought and flood in the background state. This is why in the Pacific Northwest a signal emergence is earlier, because they don't have as many swings between wet and dry, and lo and behold, you actually get a pretty early and imminent even, given where we are now since we're here, emergence of increasingly extreme precipitation events. Likewise, even in the Colorado Basin and the Great Basin, it's a bit earlier than California because there's actually less variation there. But my point is that because this is always backwards looking, we don't have 20 years of data, 21 years of data of a 2020s like climate. So if we want to know what this value is in 2024, so we are here, we actually need to be able to look forward into the future and observe the future as well as part of the past. We can't do that. We can't actually observe what's truly going to occur in the future. So my point is this: it may in retrospect turn out that the signal, when we extend this curve up to 2025, is different, is more detectable than it is right now if we end up seeing wetter conditions, as I think is pretty likely. And will this trend towards extremely severe droughts that is not quite what the climate models suggest is most likely to have happened in this period continue? That's maybe a question for another day. That has to do with whether we expect projected trends in El Nino and La Nina to be correct or not. And that remains a pretty big open question. But my point, I guess, is multifold. But what I really want to emphasize is this. When I talk to audiences like I am today, in the general public audience of people who are interested, of journalists, of water managers and emergency managers, I want to be clear that when we're talking about what we think the most likely outcome is, that is different than requiring 95th percentile statistical robustness for time of emergence. So the question of when can we be 95% certain that the signal has emerged and isn't going back is a different question from what do we think the most likely outcome is today or in 10 or 20 years from now as in this sort of segment of time. Climate models suggest the most likely outcome in California is that the likelihood of extreme precipitation events has already increased and will probably start to increase. That's what we continue to increase. That's what we see on this map through 2023 climate model projected trends, even though we don't see them in California. But the philosophical question is, if the actual extreme precipitation events haven't robustly increased, and climate models say that they should have, on average, though with high statistical noise and a low signal-to-noise ratio, what do we make of that? And I think it's difficult. I think it's genuinely a challenge to communicate what we mean. And I think that there have been a lot of folks who assume that these are completely mutually contradictory statements, that this trend in California has been toward decreasing extreme precipitation events, while the climate model trend is towards increasing events, although the statistical robustness up through 2023 is not high. One thing is clear. In a warming climate, it is highly likely that precipitation events in California will become more intense. Our own research suggests that for the very most extreme events, which are not assessed at 95th percentile, we're talking about 99, essentially something like the 99.9 or even the 99.99 percentile, so much rarer, higher magnitude events, I would argue that that signal is likely to emerge sooner in a physical sense, but later in a statistical sense because those events are rare. We don't get to observe them very often, and so we don't have a very large sample size. This is challenging. I don't think this really affects any of my priors about this, but it is very interesting to see what the actual observations show, which is that we're in the low end of the distribution, in the climate model distribution, of what likely will be an emergence of increasingly extreme precipitation events in California. So is this trend, like that we've seen here, and in the Pacific Northwest to a certain extent too, is this just due to something random, some random variation that will reverse itself? Because if the climate models are correct, then it's actually quite plausible that this trend will rather dramatically reverse itself at some point, because then not only will we gain the increase above the baseline that's expected, but we're also going to gain the increase from this sort of artificial decrease that wasn't likely to be sustained. But if climate models are wrong, then that's a whole different story. We're not 100% sure which one it is, but my strong inclination scientifically is that we will see a reversal of this, and we will see conditions closer to this trend. in California, will it emerge statistically robustly before 2050? Well, there's a chance that it will, according to climate models, but perhaps not. But the most likely outcome is that the coming years and decades will continue to feature increasingly extreme precipitation events. And it is notable that just this week, for example, talking about Santa Rosa, Sonoma County, we have seen record-breaking extreme daily rainfall in this part of the state, which is where climate models suggest there should have been some increase in that. So even though the long-term trend isn't robust, as we add more and more data points, there have been multiple locations that have seen record-breaking rainfall in California just over the past couple years. Down here, and down here, and down here, and up here, and here, and here, and here. And those are just the ones I can think of off the top of my head in the last 3 years. So, interestingly, despite the fact this is what happens when you have a backward-looking 21-year timeline, just in 22 and 23, we've seen record-breaking rainfall in all of these locations. So will this trend soon begin to switch direction or become more robust? My prediction is yes, and that we will see a much more, if once we can extend this to 2030 or something. So I think that this map may look pretty different as we get closer to this point on the chart. So just some food for thought. There's a lot in here. I think this is a really interesting paper, very comprehensively done. My colleagues at UC Merced were working together to actually take a different look at this from a different perspective, looking at other data sets and other forms of precipitation, including very heavy hours of rainfall, which might be expected to emerge sooner. But all in all, I think the key takeaway from this is that by most statistical measures, we don't yet have a very clear increase in extreme precipitation in California. There still, though, is likely a climate change contribution to the most extreme events, the very most extreme events, that is perhaps different from what this trend would suggest, and that might take a while to emerge robustly and statistically from the noise, simply because it's very difficult to get a large enough sample size, a large enough N, if you will, to see the signal through the noise. And it certainly doesn't help that we've had a recent period of record-breaking drought, which brings the long-term trend quite low. But as I've reflected to other people, we've also seen this year, and I'm going to bring myself back up on camera for now, since we're getting at the end of the hour, we've also seen in recent years some of the wettest precipitation events on record and some of the driest in the same parts of California. Sonoma County, Butte County have hit records for both wet and dry in the past decade, now multiple times. Santa Rosa, Sonoma County has done this now, just yo-yoed back and forth. And this is true in other regions as well. I think what's key is that we most clearly expect to see an increase in the hydroclimate whiplash in this region, and I would argue we've already seen that, and we have some quantitative evidence we'll publish soon on that front. But the key is that means that the swings between wet and dry are becoming greater. Recently, the swings to wet have increased more than the swings to dry. But in a warming climate, we actually expect that to become more balanced, where we really truly will see wetter wets as well as drier dries, leading to an even greater divergence between the two. And so the whiplash of the last decade or so has been more dry flavored than wet flavored, if you will. But it's quite likely that that will actually become more balanced by increasingly extreme wet events. And the tale of it remains to be told exactly when that signal emerges robustly in the noise. But even if we can't demonstrate with 90 to 95% confidence that that signal is there, there are individual studies for storms in California suggesting that climate change has already increased the extremity of those events by 10, 20% or so, which is in line with thermodynamic expectations. And so the answer could be different for the most extreme events, so the very rare events, for the more ordinary ones. The answer could well be that we've gotten unlucky and experienced an unlikely but real iteration of climate variability that has resulted in less increase in extreme precipitation events than we would have expected by now. In fact, there is evidence from my additional colleagues at UCLA that natural climate variability has suppressed the human-caused warming increase in extreme precipitation events in the West, and that may rather dramatically reverse itself pretty quickly at some point. And I tend to think that's probably true. That is my instinct for what things will look like, is that some decade, either this decade, the next one, or the one after that, we will see a pretty dramatic reversal of this, and that 21-year moving average will start to move in a different direction, and we won't know except in retrospect. And the last few years could be the early contributors to that, because we've seen some very extreme precipitation events in 2021 through 2024. And we'll continue to keep an eye on it. We'll continue to update, and I'll continue to provide that broader context. So we're at the hour, a little bit over the hour. I want to take a look to see if there's any more last-minute comments that I want to answer, and then it might be time to call it a day. Occidental storm total from Steve of 11.5 inches. What does Southern California look like in the next couple of weeks? Some rain from this event and maybe a follow-on event, but nothing dramatic. So hopefully enough to tamp down fire season. Maybe not much more than that. Yeah, I can send a link to the paper that I was talking about. It is open access, so let me just pull that up and I'll just put it in the chat. Folks can take a look if they're interested. Sorry, I got my windows all mixed up here. Question from Rebecca: is La Nina still on the books for this winter? Or have El Nino, La Nina impacts changed due to climate change? Two very different questions, and they're not easy to answer in the time I've got left. But La Nina maybe not this winter, not as strong as initially indicated, but so I'll talk about that in a future live stream when I have a little bit more time. The El Nino, La Nina impacts due to climate change, I've touched on that before. I think it's worth a full session soon, because it actually strongly plays into this discussion of the paper I was just talking about, because at large scale, one of the reasons why California has not seen a larger increase in extreme precipitation events, at least proximally, is because we've seen a trend toward more La Nina-like conditions in the Pacific in recent decades, contrary to climate model expectations that we'd see a trend toward more El Nino-like conditions. Now, there is a very active debate in the scientific literature right now whether that is just bad luck, if you will, random chance, and this trend will eventually and perhaps rapidly reverse itself, where we will in fact see a strong trend toward more El Nino-like conditions in the near future. But that's not guaranteed. And this is probably a big part of the reason why those trends look like they do on that chart I was just showing. And the answer is we don't know yet. If the climate models are perhaps wrong about that El Nino-like trend, or about the La Nina-like trend that we've observed versus the El Nino-like one that we should have observed at this point if they were correct, probably. So that's going to be a big question moving forward. And it will affect California hydroclimate and the risk of extremes. So I still think that the likelihood of the very most extreme wet events increases no matter what. It's very hard for it not to. But the question about the more ordinary extremes and the balance between wet and dry extremes as whiplash increases will very much be affected by whether or not we see a trend toward more El Nino or La Nina-like conditions, and therefore whether the climate models are correct in their representation of those trends. So that's a very big, active question at the nexus of climate science and regional hydroclimate studies. And we don't really have a clear answer yet. So stay tuned. That's going to be a big topic of conversation moving forward. All right. Well, again, I think today is going to be an awfully wet day in Sacramento, San Francisco for much of the rest of the day. And as the rain continues to move through the North Bay, some additional flooding, although it looks like the heaviest rain is probably past Santa Rosa now, but it's still pouring in Rohnert Park, Petaluma, Marin County, Napa, and into the valley. So there is some potential flood risk today. Again, this is not an extreme flood risk day, fortunately, because The conditions leading into this event were quite dry, but Santa Rosa has seen all-time record-breaking precipitation, as has much of Sonoma County. So yet another region of California breaks all-time rainfall records with this event. I think that's about all I've got for today. Thanks for joining, and I'll try and have a slightly a conversation next week scheduled slightly longer in advance so more people can join, although I see that many people have today. Again, it is very helpful if you like the stream while it's live, and if you do indeed like it, if you appreciate it. And if you subscribe, you'll be notified when I have these sessions, hopefully in real time. And it helps build that subscriber base. Spread the word and stay safe and dry out there. The good news is in Northern California, fire season is pretty definitively over and will be mitigated by the rain in Southern California too. So there is always that silver lining. I know there's some folks who were scrambling to get their prescribed burns done before all the water came in, and I think some of them did. Southern California, that window will probably remain open for a while still. So, have a good weekend, everyone. And as I said, stay dry. And if you're in the North Bay and a few other spots that I highlighted, be careful with the flood risk today, and stay off the roads if it's ponding up, because it will be probably in parts of the Bay Area and Sacramento I-80 corridor later this afternoon. All right, folks. Talk to you later.